Hi, this is question number 6 from AQA Further Pure for January 2010 paper. This video is going to be split into 3 parts. First part, you're going to have a go at trying the question yourself. The second part, I will give you a hint and you can use that to have a go at doing the question yourself. And for the third part, I will go through the answer to the question. So I'd like you to read the question and see if you can have a go at doing that now and pause the video. Okay, for the next part of the video I'm going to go through a hint. So what we're asked to do is for part A is find the value of P for which the planes with these equations here are first of all perpendicular and then parallel. Okay, so what we need to know is that when two vectors are these here are the normals to the planes, and if our planes were perpendicular to each other, what would that make the normals to each other? Well, if our planes were perpendicular, then our normals would be perpendicular to each other. So that tells us something about the dot product of our normals. The dot product of our normals should be something. Similarly, if these planes are parallel to each other, then the normals would also be parallel to each other, and I would then need to decide how I can decide what values of P are going to make this vector parallel to this vector here. Okay, in part B we're told that P is going to be equal to 4, and we want to first of all write down a Cartesian equation for each of the planes. Okay, so I'm just going to write down here for part B that you could write R as x, y, z, because it's just a general point, and that's dotted with 6, -3, 2, and that's equal to 42. So we could work out the dot product of this, and this should give us a Cartesian equation for this plane, and we could do it again for this plane. For the second part of B, we're asked to find in this form here an equation L for the line of intersection of the planes. When we're finding the line of intersection, we need to, this was B part 1, so for B part 2, we're looking for something that's going to be in the form R is equal to A plus a multiple of the direction vector B. So A is just going to be a point on the plane. So I need to use the two equations of the planes that I've got to see if I can find a point on the plane. So any point on the plane will do. Any point on the intersection will do. And B is going to be the direction of the intersection. So again, I want to decide how I can use the normals to these here to decide on what the direction of the intersection is going to be. Okay, and then for part C, we're asked to determine a vector equation in this form here for the plane which contains L. Now remember, L is the equation of the line of intersection of the planes, and we're also told that this point passes through 37, 30. So I should already know that this equation of a plane is going to be made up of a point on the plane and two non-parallel direction vectors. Now because I know that L lies on the plane, I should already know what one of the direction vectors are. I'd have worked that answer out earlier. So I need another direction vector, and I also need to know a point on the plane. Again, we should already have that information. Okay, there you go. If you want to now pause the video and have a go at answering this question, and I will go over the answer shortly. Okay, this next part of the video is going to be the full answer to this question. I'm just going to make this a little bit smaller to give me a little bit more room, and I'm just going to get rid of that for the time being. Okay, so for part A, I'm first of all going to find something that's perpendicular to both of these planes. So in order to find the value of P so that these two planes are perpendicular, that means that the dot product of these two is going to be equal to 0. So for part A, I want the dot product of the normals, so that's a normal to the first plane, and when I dot it with the normal to the second plane, if these two planes are perpendicular to each other, the normals will be perpendicular to each other, so the dot product is going to be 0. So expanding that out, I've got 20, so that times that is 24p plus 6, take away 3p plus 6 plus 2, and we want that to be equal to 0. So that means that we're going to have 21p is going to be equal to negative 14, so p is going to be negative 2/3. Okay, so when p is negative 2/3, these two planes will be perpendicular to each other. For the second part of this question, we want them to be parallel to each other, so that means that this normal needs to be a multiple of this normal here. So it's going to be equal to a multiple, I'll just use the letter A to stand for, of this here. Okay, so well, this is definitely 1 and this is definitely 2, so that tells me that the multiple that we're looking for is 2. So we're trying to say that it's going to be equal to 8p plus 2, 2p take away 2, 2. So we're looking for values of p that are going to make these two numbers the same and these two numbers the same. So 6 would have to be equal to 8p plus 2, which means p would have to be equal to a half. So this should be our answer, but we'll check it on the other one as well. So negative 3 is equal to 2p take away 2, and again p would have to be equal to a half. Okay, so our solutions then, the values of p would be negative 2/3 for this bit here, and a half for this bit here. Okay, I'm just going to tidy my work up and I'll move on to question B. Okay, for part B, we're told in the case p is equal to 4, we need to write down a Cartesian equation for each plane. So I'm going to I'm going to write this as x, y, z. Equal to 42. So that's going to tell me that 6x take away 3y plus 2z is equal to 42. So that's going to be my first equation. And for the other one, well, I know p is 4, so that's going to be, and I'll write it as x, y, z again. And I've got 17, 2 and 1, and this time this is going to be equal to -7. Okay, so I've got 17x plus 2y plus z is going to be equal to -7. Okay, for the next part of this question, we need to find out the equation of the line of intersection between these two planes. So for this question, we're going to split it into two parts. First of all, we need to know the direction in which that intersection line is going in, and then we also want to know, so this will be the direction the line's going in, and we also need to know a point that it passes through. Okay, so I'm just going to tidy this up a little bit. Right, I'm going to start by finding the direction vector of the intersection. So I can find out the direction vector of the intersection by taking the two normals to the plane and finding the cross product of the normals to the planes. So that will be perpendicular to the normals, and it will also be the direction of the intersection. Okay, so one of our normals is 6, -3, 2, and the other normal is going to be when p is 4, 17, 2 and 1. And the cross product of these is going to tell me the what's perpendicular to both of these, which will be the direction of the normal. So finding the cross product, I will get so that's going to be -3, take away 4, which is -7, 6, take away 4, which is -28. If we take the negative of that, so it will be 28, and here we're going to have 63. Okay, so that's going to be the direction vector d of our line of intersection. Now, because I can spot that these are all divisible by 7, I'm going to write my direction vector as, and I'm going to divide each of these by 7. Remember, it's a direction vector, so as long as I multiply, divide them all by the same number, it's not going to change direction. So that would be -1, that would be 4, and that would be 9. So I've got some nicer numbers to work with now. Okay, so that's the first part of what we're going to do. Now what we need to do is we need to work out what this here is. We need to work out what A is. Right, so I just need any point that this intersection line passes through. So I'm going to choose the value of one of the coordinates. I'm going to choose my x coordinate to be 0. Yeah, so I'm going to let x equal 0. And as long as this line passes through a point where x is equal to 0, I should be able to solve this equation and get some unique answers for y and z. So if x is equal to 0, my equation 1 is going to be -3y plus 2z is equal to 42. And when x is 0, this equation is going to be 2y plus z is equal to -7. Okay, so I should now, because I've got two equations and two unknowns, I should be able to solve this simultaneously now. So what I'm going to do is I'm going to do 2 lots of this equation, take away this equation here, and that should eliminate my z. So 2 lots of this is 4y, take away -3y gives me 7y. 2 lots of z, take away 2z is 0, and then I've got 2 lots of -7, which is -14, and I'm going to take away 42, which gives me negative 56. So that means that y is going to be equal to negative 8. Now I know what y is. I can substitute that into here. So that's negative 16 plus z is equal to negative 7, which means z must be equal to 9. So my a is going to be equal to 0 is what I chose the x to be, negative 8 and 9. Okay, so now I'm ready to write down the equation of the intersection. It's going to be r is equal to, and it's going to be 0, negative 8, 9 plus lambda times negative 149. And there you go. Okay, right, so before we move on to part C, I'm just going to tidy up. Okay, for part C, we want to find a vector equation for a plane that contains our line L, so it contains this line here, and it passes through the point 37, 30. So this equation of a plane in this parametric form means that we need a position vector so a point which the plane passes through, and we need two non-parallel direction vectors. But I already know one position vector because I know that it passes through this point here, because L passes through this point here, and I also know one of the direction vectors because I know that the direction of the intersection was this here, so L has this direction, so I can put that into there. So the only other bit of information I need is I need to know another direction vector. Well, because I know that this passes through the point 37, 30, and it also passes through the point 0, negative 8 and 9, then what I can do is I can find another direction vector. So I can say that W, the direction vector W, is going to be equal to, and I will do 37, 30, so one position vector take away the other position vector that I know is on the plane. So that tells me that that's going to be 30, 15, 21. So that's going to be my other direction vector. So I can say that the equation of this plane is going to be r is equal to u, and I can choose this point or this point. I'll go with that one. So I've got 0, negative 8, 9 plus beta times and vector v, we chose this one, so negative 1, 4, 9 plus gamma times and this is our other direction vector, 30, 15 and 21. I could have simplified that. I could have divided all of those by 3 if I wanted to, but there you go, and there's our answer for part C. Okay, thanks very much for joining me for this. Hopefully you found that useful. I will see you again next time.